sorry about that. I pressed stop by mistake, so I'm going to carry on with this. So I'm going to use the equation that they've given me. Time equals distance multiplied by the square root of mass over 2 energy or 2 kinetic energy. And I'm going to rearrange this because I know the time, I know the energy, and in the last question that I've just done, I worked out the mass of a titanium 49 ion. What I don't know is the distance of the flight tube. Okay, so that's what I'm going to work out first. If I can work out that, then I might be able to work out the time it takes for the titanium 47 ion to travel along that tube. So I'm going to rearrange this equation so that I get distance on its own, and to do that I'm just going to take, square root of m2e, and I'm going to divide both sides by it, so I isolate d and get d on its own. So if I do that, I've got time divided by m over 2e equals my distance. To put my numbers into this calculation, I need my time that I've got given here, so that's 9.816 times 10 to the negative 7. Divide by my mass. My mass of my titanium 49 ion I've got over here, so that's 8.137. Square root 8.137 times 10 to the negative 26. Divided by 2 lots of the energy, so that is 2 times 1.013 times 10 to the negative 13. Okay, so I could do this in my calculator. I would, again, if it's an exam, I'd take it in steps. So I'm going to sort out this sum on the bottom, so I'm going to keep my top number the same, and then divide by the square root of this divided by this, which gets me 6.3374 10 to the negative 7. Once I've done all that in my calculator, that gets me an answer of 1.549 meters. Okay, so that's the length of the flight tube, and again, if you check that to kind of what you know in terms of the real world, 1.5 meters or so seems like a sensible number for the distance of a time of flight mass spectrometer, so it looks like it's a good answer. Okay, now if you got this far, you actually get 2 marks from the mark scheme for working out the distance of that flight tube. Okay, so what I'm going to do now is I'm going to go back to this original equation that I've got here, because now I know the distance of the flight tube. I know the energy is going to be the same. What I need to do is recalculate this equation, but for the mass of a titanium 47 ion. So I'm going to do the same sum that I did before for the last question, so this one here, except for titanium 47. So I'm going to say, let's do this in blue, 49, sorry, not 49, it's 47, isn't it? 47 divided by Avogadro's number, 3, divide that by 1,000, because I want that in kilograms, remember. That gets me 7.8047 times 10 to the negative 26. I can then, let me just siphon that off, say that time is equal to the distance, 1.549, multiplied by the square root of 7.8047 times 10 to the negative 26, divided by 2 lots of the energy, 2 times 1.013 times 10 to the negative 13. I can work all of that out in my calculator, and I get a time of flight of 9.614 times 10 to the negative 7 seconds. Just tidy that up a bit. And again, what I would do is I would check that against this time of flight here. So this is for titanium 49, this is for titanium 47, and you'd expect this one, titanium 47, to be a shorter amount of time. It's going to reach the detector first because it is lightest. So I've not quite got the third mark yet because I need to give this to the appropriate number of significant figures. So if I look in my question, I think 2, 3, 4, 2, 3, 4. So I've got four significant figures in my question, so I need to give that to 4 significant figures. And there's my answer, and that would be my third mark.